Cool. Welcome everyone to the 2020 APAC Groundbreakers virtual tour by APAC OUZ. And this year our event would be the biggest one ever done, with 174 sessions that would be including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages. So please remember to register to as many sessions as you can, and all sessions would be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during the 2 weeks by posting questions or comments directly in the playback session page. But yes, I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Python, the latest and greatest for Oracle database applications by Christopher Jones. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Christopher. Take it away, Christopher.
There we go. Let me know if you can't see the screen. So,
yes, it's all good.
And hopefully you're seeing the correct screen as well. So welcome to new and old friends. I see some names that I recognize on the invitees. That's good to see. I think you all know who I am by now. I'm a product manager in the data access team for Oracle Database. So I'm the sort of general technical go-to person liaising between some Oracle development groups, management, and with you as our customers and users. I get to write some code, do some documentation, create samples, create and review project specifications and feature proposals, and do a lot of other tasks to make life easier for you as developers, and also for our own internal Oracle developers as well, to make sure that they can get content to you. And of course, I get to do demos like this one today. So my wider group looks after a whole bunch of language APIs for accessing Oracle Database. I particularly focus on the C stack. And today, obviously, we're going to speak about the left-hand one there, the Python and the CX Oracle API or module or driver or whatever you want to call it. I spent a number of years working solely with the PHP community, and then have broadened my scope and now look after a bunch of languages, some of which we contribute directly to, others we liaise with. And I really do need to give a shout out to our maintainers out there, community maintainers who are looking after some of these great drivers and APIs for accessing Oracle Database, and the frameworks and the Rails adapters. Yes, Honda, I saw your name on the list. Thank you very much for all the work you do there with Ruby on Rails. I also have overall package responsibility for Oracle Instant Client. So if you have questions, feel free to bug me about that. I can help you or pass you on to the particular product owners as necessary. So I looked at the abstract that we wrote. These are the sort of main themes that I pulled out from there. Initialization, some changes in the latest version, so I want to talk about that. Performance is always an interesting topic, and high availability, very important in many places. JSON and this document storage, the SODA, Simple Oracle Document Access. I'm going to cover that a little bit, and then I'm going to go into some provisioning in Docker and just introduce Docker to you. So in 4 points, just to do a warm up, Python, structured, object-oriented, portable, robust, available, has lots of frameworks and ORMs, a lot of data analysis packages. Pandas is almost certainly taking over from the R language, highly organized conference training systems, a lot of use cases out there. We see a lot of interest in our sessions and the hands-on labs that we're running. And there's a new Oracle Live Labs. You may have come across that site. There are a lot of labs you can run there yourself, self-paced training free. And there's a Python lab in there as well. I mentioned times 10 on that slide, same API as Oracle Database, so it's the same stuff I'll be showing you today. There was a rough benchmark somebody did. He stopped at a certain point before really pushing it. It's getting up to 11 million queries a second using times 10 and the driver I'm showing you today. Your mileage may vary. Obviously, with Oracle Database, it's going to be less than that. But yeah, it's certainly a scalable solution there to use in many places. CX Oracle, in just a one slide. It's the interface, the API for accessing Oracle database, lets you execute SQL, PL SQL statements, and these new SODA calls for document style access. Long history, lots of functionality, most widely used of all of our database access APIs in the space that I look after. Gets about 1 million downloads a month from all you people provisioning in Docker and continuous integration chains. It's available from the PyPy repository, so just a standard pip install. I'll show that at the end. There are also RPM packages for those in the Linux space, the Oracle Linux. We have a yum.oracle site where you can download those from, and you'll see that a little later as well. I'm not going to read through this slide. Lots and lots of features, open source. You can go and modify it if you want. You can bug us if you have issues. Low-end, high-end features available there. And we're going to cover some of those today in the time we have. Of course, we can't cover a lot. Let me go straight into a demo. And for those who haven't seen Jupyter, so just checking you can see my browser window now. This is Jupyter. It's another package you can install with pip install Jupyter. Note the spelling. Gives you the sort of fantastic web framework. This is the first time I'm running the demo like this, and I can see lots of improvements, but if you have comments, please let me know. So just as a refresher, CX Oracle is a thick driver, so you always need some kind of Oracle client libraries. And these are the things which talk across the network to the database. So pip install for CX Oracle, and then CX, the Oracle call interface you download separately. So let me just run this. This is sort of steps through, so please try and just focus on the bits in the middle. A lot of this text, as we'll make it available to you, will be useful for you to click through later. So one thing new in CX Oracle 8, which came out in mid this year, is that we have a new init Oracle client lib function. And in the old days, you might be setting a path environment under Windows. You might be doing some fiddling under Mac OS to set where these Oracle thick client libraries are. Now on Mac OS and Windows, you can make use of this new feature. Sadly, on Linux, you still need to use ld or ld library path to set the library search path. If I run this, it's just going to go through and then print the error, the output at the very bottom. Globalization, another change here in CX Oracle 8 over the last year. I don't know who came to or saw the sessions that I gave at this version of the conference last year. Covered a lot of ground here. I'm just picking out some of the key things which have changed. So just set up some credentials, which I'm going to use later for my demos using Easy Connect syntax. For those who don't know, yes, you can avoid hard coding passwords and things by using external authentication. So this is the traditional way of setting the encodings that you would use in CX Oracle. Varchars and then the national character sets, nclobs and varchars, you'd have this n encoding parameter. Note that these names here are not the sort of standard Oracle AL32, UTF-8 names. These are the Python encoding names. And then when we run that, you can see that the output from the print is obviously just the values that we passed in. The key thing here is that with CX Oracle 8, the defaults have changed to be UTF-8. So in fact, you no longer need to do this code that I had up above. But if you're using older versions, make sure you do this. And the other important thing is that if you were setting the environment before you started Python, so not passing these n encodings, and you were setting it in the NLS-lang environment variable, then that encoding is ignored and we use UTF-8. Really shouldn't be an issue because most things should be running fine under UTF-8, so you're probably not going to notice any difference. But if you do have an issue, then you just go and modify your scripts and use UTF-8. That's one of the key changes there in CX Oracle 8. Connection pooling. So you'll see this come up time and time again in this talk. Obviously, you need a connection to the database to actually do any work. Highly recommended for lots of cases. Obviously, web apps, web services, doing lots of short requests. Creating a connection to the database is expensive. If you look at the diagram lower down, you've got to start this process. There's a network listener that's got to be woken up. You've got to start this process, allocate memory, and then at the end you'd have to close it all down again if you're just using a standalone connection. That's kind of an expensive operation in Oracle. So we recommend using a pool. So the pool pre-creates these. and then the application can just use the ready connection whenever it needs to. If you have a small number of connections which are idle for some time, also a good case for using a pool, because the pool has some high availability features. So let's just run through standard. This doesn't have any output, so you won't see any output. Standard kinds of settings that you can do, pool sizes, increments, how it should grow if the pool needs to grow and shrink. One thing which you probably almost certainly want to do is add this threaded equals true mode. And this is going to be useful if you're in any kind of web service where you're handling multiple requests at a time. So you need that to make sure that the CX Oracle and the lower libraries are doing their proper threading, handling, and not stamping over memory. Pro tip, use fixed size pools, and that avoids things like connection storms. Because in the morning when you wake up and the connection pool has shrunk back down, everybody wants to start doing work. Database is trying to actually execute that work, and then now you're asking it to create those processes. So it's getting a double whammy there. So that's a pro tip that our real world performance tuning team really like to see. Session state. So one common thing that people do when using connections is they run some kind of alter statement. As you can see here, alter statement to set some kind of state for that connection. Now, in the session pool and the connection pool, terms used interchangeably here, technically it's a session pool for documentation reasons, but from practical user point of view, it's a connection pool. When you get out and put back connections into this connection pool, they're going to retain session settings like these alter values. And typically, that's a whole round trip to the database. That's an execute that you have to do. Notice, by the way, that I'm setting two things in the one statement, the date format and the language. So I don't have to run two alter statements. So that's an optimization. And then obviously further optimizations, you can wrap everything in a begin end block and do a whole bunch of SQL statements. Again, that's just one execute statement, so more efficient. But the point of this particular demo is that when I create the session pool, I can pass a callback statement, callback function name. And this function is going to get called once per connection in the pool. So I have here maximum 4 connections in the pool. So this is going to get called 4 times. Yes, okay, so connections can grow and the pools can grow and shrink. And of course, if a new connection comes in, then this is going to have to be rerun for that new connection. But at the sort of standard think about it model, it's going to run 4 times because we've got 4 connections in the pool. If I go down to this little sample here and refer back to the code, if you don't have the pool, okay, so we have 4 connections in the pool. Let's say I'm doing a web service with 1,000 requests. So I have to call my do work, so I have to get a connection from the pool. If I don't have a callback, I've actually got to run that execute statement. So I'd have to do 1,000 calls, and then my app probably has some kind of query in here. And so that's another 1,000. So total, I get 2,000 database calls just for this application, just for 1,000 user requests into the service. With this init session callback, I don't have to do those alter calls for every single pool.acquire call when I get a connection from the pool. I only have to do it once per connection which exists in the pool. And obviously I've halved my workload in this particular case. So this is a very efficient way to set that session state, which I know most of you are trying to use in connection pools and connections. There's tagging capability as well, which you can use if you want particular connections in particular scenarios to have different kinds of state. You can, when you do a acquire, you can say I want a particular tag, and then that will get passed through here, and you can do some testing on it. But for most people, they just want the same state for every connection, so we can ignore that. Closing connections, obviously quite important, because you do need to release things back to pools to be reused. I know Anthony Tuaninga, who created the extension, prefers to just let the driver tidy up things when things go out of scope. And that's perfectly fine if you have small methods and procedures. But otherwise, you might want to do explicit closes of your cursors and connections and make sure you get the ordering correct. Okay, let me run on. So speak a little bit about queries and queries in the Oracle sense, the true selects and with returning data, not any particular SQL. So I've got my initialization that we ran before, so my usernames and passwords, which I'll use later in the script. So round trips, I spoke a little bit about. Round trip is that trip from the application to the database and back again. That's going to cause scalability issues because you have the network listener has to wake up, interrupt handlers, database has to do some work, send stuff back. So you want to minimize those. You don't want to overconnect. So connection pooling is good. You want to only fetch the rows you want. So, use a SQL where clause, columns, only get the data you want. And don't overuse things like commit and rollback, which are trips across. And then obviously commits themselves actually have to do work in the database as well. So that's a sort of general guiding thesis we have here for application development in our team. So you would have seen possibly the standard execute model. You get a cursor, you've connected already as previous steps connected. This is an internal tuning option, so it has no effect on the number of rows which are going to be returned to the application, but it just reduces the memory size from the default, which is 100, and is an optimization that you can put in there. Fetch one row, print the row, comes back as this tuple here. The more interesting cases are where you perhaps have a large number of rows. You have a huge number of rows in a table, can't fit them all in memory at one stage. Instead of using fetch one in the previous example, we might be using fetch many. And new in CX Oracle 8 is this prefetch rows, and I've got some good examples of that later. But these are sort of internal tuning parameters, so they're not things you have to worry about are going to affect anything except the performance and the memory use of the application. All of the fetch many, fetch one, fetch all methods are just going to return all the data that you want at that time. This is just used internally in the buffering. So if we run this, obviously I don't have it's not a huge table, so 1,000 is a bit of an overkill for this, but you can see that I fetched in batches multiple rows from the table, printed the rows, and broke the loop when we didn't have the full 1,000 that we were expecting back from the database. The very interesting case is this, where you actually know how many rows you're going to fetch back. So this is using the Oracle fetch next to limit the rows, limit the number of rows returned. And we know here we're going to fetch 5. And we're binding max rows into this max num rows. And the key thing here is that with the prefetch size, we're setting this internal buffer to be 1 greater than that number of rows that we know that we're going to fetch. And this gives you fewer round trips to the database. Again, I've got the sample I just show you beneath. Fetch all, just showing for the sake of showing everything, gets all the data back in one hit. And obviously we can loop over it and it'll print out all of the rows. So we have 2 internal tuning parameters, prefetch rows and array size. They're used by different layers of the Oracle code and the Oracle libraries. And Oracle internally, which you don't see in Python, has a sort of separate prepare stage and a separate, a separate execute and a separate fetch stage. And the buffering of these 2 operations, of these 2 parameters is controlled at those 2 different layers, 2 different function calls. I've tried to explain it before with diagrams and it tends to confuse people. The best way is to perhaps look at this example and just see how it actually affects in real life. So I'm doing here a query. This just gets the round trips in the client. And you can see I'm doing get round trips. And in the middle, I'm doing some kind of load. So I'm fetching a number of rows and printing output at the bottom just to show how many round trips were taken depending on the values of the prefetch rows and the array size. Here I'm doing the call. So let's just run this. And you can see that round trips vary quite a lot depending on the prefetch rows and the array size. I think a nice little one to look at is actually the second one here. So fetching 100 rows with the default values. So if you don't set any of those parameters, this is the default. So it's going to take 3 round trips just to do this. One of those is checking for end of fetch. But if you actually set this prefetch rows to 101, that's the only change here, then the number of round trips goes down to 1. Now, there's an extra memory copy if you do the prefetching, and that sometimes can appear to slow your applications down if you're just testing in a very fast network on a development machine. But once you start scaling out to large numbers of machines, you might find that actually that it reverses and the round trip cost is much more significant. So you probably want to do some testing in production, or just set this to round trips to minimize the number of round trips, and then know your application is going to be scalable and you're not going to have to come back and revisit it when somebody complains about it. So that was new in CX Oracle 8. We tried to hide it away so you didn't need to set it, but it turned out that it was much better to give you the control. So you have this new prefetch rows option. It doesn't actually affect fetching for ref cursors, although I saw some work on that, so that should be coming up in the next CX Oracle version for ref cursors. But for normal queries, it will work fine. Let's go, oops, ran that again. So let's look at lobs. Two modes with lobs: streaming mode, which is the default for historical reasons. Great if you're doing large data streams, videos and things like that. Not so good if you just want to get a large string out, a couple of megabytes, something like that. The API for lob streaming, as you can see here, you get a cursor back. You get a lob locator back. It's just your column, and then you get various methods of that lob locator. You can fetch here. I've read everything, but you can fetch chunks of data if you want to just fetch chunk at a time. And fetching each of those chunks is going to be another round trip to the database. So it can be kind of slow, but obviously if you don't have enough memory to hold the whole lob in memory at once, then you're going to need to use that. The faster way for most people is to fetch as string. And if you set up an output type handler here, which you can easily do, cut and paste this code. We have had some talks about how to make this a little easier to do with an option, but for the moment, this is it. This is just going to return you the string directly. And as you can see, same code as above. And now I just get the data back directly. It even looked faster. Anyway, maybe this size, it probably wasn't. You can do it as blobs as well if you want to. So that's just something you can cut and paste there if you like. And this is just a benchmark which we ran at some stage. Your mileage will vary depending on the network speeds and the size of the rows and lobs you're fetching. But generally, it's a lot faster to fetch as string using that second method that I showed, rather than fetching as a streaming case. Okay, got a lot to get through. So, again, just set up, creating some tables, yada, yada. I wanted to speak about batch execution. And this is particularly important if you're going to be doing a lot of data loads. Just like that array size for fetching data, where you fetch batches of data back at a time. So one round trip sends lots of data. This is the opposite, so sending lots of data in one round trip. So if you look here at this execute many, I'm just executing the insert statement once. And so the statement and all this data will go across in the one round trip, get inserted, and I'll get the data back. Obviously, when I query it, it comes back directly. So make use of execute many where you can, and make use of other things such as wrapping things in PL SQL blocks to avoid executing multiple statements. If you're doing queries, do as much as you can in one query without having to do multiple queries to join. Make use of the SQL relational model that you've got. I've got a little benchmark here. I don't want to go right through the code, but it shows a nice little plot here in Jupyter. This stuff is available, so it's a nice way to show output. So I'm just doing execute many, and if I run it, so I am looping the number of rows that get inserted varies, and you can see that the time and then the plot down the bottom for the time. So the number of rows, 10 to the power 3 rows in a loop, executing, 10, 100, 1,000, so executing 1,000 execute statements to insert 1,000 rows, very slow compared with calling execute many once. So that's a good tip to make your applications very efficient. Now, I want to talk a little bit about JSON. I knew time was short, and my colleague, Beda Hammerschmidt, gave a great talk last week as part of this conference series on JSON and some of the new features, particularly things like the autonomous JSON database, which is one of the new database services we have at Oracle in the Oracle Cloud. Remember, you can get free cloud accounts, and he showed a lot about that, so I'd recommend going and looking at that if you have access. There are also some blog posts that I have up there connecting to autonomous databases, a new autonomous JSON database. There are a number of resources out there if you're interested in the great details. But from the Python point of view, the key thing is that we have this thing called document access, simple Oracle document access style, and the API is available in Python, Node, PL SQL. It's available in SQL Developer and SQL CL and Java and all sorts of places. So it's a great way to deal with documents. And by default, this is a key thing, those documents are in JSON. They could be in anything, but by default they're in JSON. So there's a natural affinity between SODA and all this new JSON technology that Oracle's producing. So you need some kind of grant. You also need to kind of create table because things are backed by tables, but you don't see that. I've done that before. This is the new API in CX Oracle, not new this year, but new in earlier versions. You can just create a collection. So you can think of collections as kind of table if you want to think about it that way if you're a bit unsure. And then you can insert documents and you can think of those as rows if you're still trying to get it in your head. There's not going to be any output from this because there's no output. But you can see the key thing here is that I've at runtime decided that I wanted to change the schema. So I was able to add and augment that collection which is stored in the database. Let me just scroll up a bit. And if I run, and this time I will get some output, you can see that I'm getting keys. And then when I have document keys, these are auto-generated. You can change that if you want, but by default, it all works nicely. I get the key back for that document I just inserted. And the next stage, I will use that key and then get the same document back that I just inserted. So I have this very simple API. Notice this is a kind of chained methodology. So you get filters. So you get a full syntax there, query by example model. And here you get filters, you get regular expressions. This is obviously a like. And I can pull back all of the matching. I think I've run this a few times on my database already. So I've got a few elements in that collection already stored there. And then find operations to count and delete and all sorts of new features coming up all the time. So I'm not going to go into that in great detail, but there's a lot of JSON functionality. You can execute statements and convert relational tables into JSON and vice versa, or you can do things like the SODA API. Okay, I've only got 15 minutes left. Let me go back to slides, and I wanted to cover a little bit about high availability for you. So high availability, obviously very important. Typically as an application developer, you start seeing connections hang. You want to mask those effects from the end user. If there's planned maintenance, you don't want people to be aware of that. Unplanned outage, a database node has gone down, you don't want them to understand and be frustrated by that. So you want to move work to different instances. So a lot of the sort of high-end Oracle stuff assumes you've got some kind of duplicate instances, rack or data guard, one of those kinds of things running in the back end. But there are some things that we can do at the driver level, which I think are very useful to know. So I don't have a good name for this. In the past, I've tried to call it something like simple high availability, but actually, some of those high-end things are actually even simpler to use, so that's not a good name. But this is sort of developer level or the client-side high availability. So you know that we have some configuration files on the client, SQLnet and TNS names.ora. There's a lookup hierarchy where they are, so make use of those. But there are a lot of options there that you can add in to into the SQLnet.ora to give you a better availability of your applications, particularly things like this outbound connect timeout or TCP connect timeouts that can bound the times your application will get an error back if the database connection is down, and then in the application you can decide whether to give the user a nice message or try reconnect or whatever you'd like to do. One of the other things we've seen useful, expire time, particularly if you have a firewall which is killing connections. Maybe you're running an Azure connecting to Oracle Cloud database, and Azure is killing the connections, idle connections every 4 minutes. And creating connections is expensive, so you don't want that to happen. So if you can't fiddle with network parameters, which is always hard in the cloud, you can set this expire time setting to send keep alive packets across the network to keep the connection alive. So that needs a recent client version, so make sure you are keeping up to date. Easy Connect Plus, which came out with 19C, lets you set a lot of these things on the command line, so you don't even need those on the connection string. So you don't even need a configuration file. You can see there I set in red the connect time and the expire time. Syntax is quite extensive. We have a white paper on that, which I had up, but which I do not have up anymore. But there's a white paper, a technical paper up there, which you can look at. Okay, what else can you do? Obviously, connection pool, mentioned that a few times. Note that they don't guarantee to return a usable connection because they're not wasting time going across a network unless you've got that expire time on. The technology underneath connection pool will actually try and make sure it does its best for you, but doesn't guarantee that it's going to return a usable connection. It's certainly going to be better than using a standalone connection. Connection call timeout came in a few versions ago. That's a great way to bound times. So you can set this in your application. So this is a Python method, Python attribute, sorry. And you can use that to cancel and automatically clean up any query or statement which is taking too long to execute. So you've got some control here in the applications. Obviously, you can't assume connection is going to be usable between the time you acquire them and the time you use them. So you're always going to have to do some kind of error handling. So you've got to handle those errors and make sure you do graceful recovery from them and not print out messages to the user. Oracle's got a lot of the high-end stuff. I'm just going to mention the application continuity a little bit and how that works. It is simple. It's pretty much enabled by a database server setting. There's nothing in the application to configure. Applications will just work with it. Yes, there are things you need to know as developers where it will and won't work and side effects, but in terms of enabling it, it's a database service. The network service, you can enable the high availability features like application continuity. Application continuity, by the way, works great for connection pools. If you're not using our connection pool, then we have something called transparent application continuity, which tries to guess when you are and aren't using connections, so it can do its work. So how does it work? Normally, if things are working fine, you have you get to a get connection. So that's the start of the request that you're going to do some work. The client libraries, which are below CX Oracle, they capture the calls, inputs, validation data, and if everything, your commit works or you roll back, your application succeeds, everything works fine. It just purges those captured calls. But the trick is, what happens if things aren't fine? So there's a replay on failure. And yes, there are some blanks in there. I'll go through those later. But something failed, so then we go on. We have to create a connection to a new database. That's step 2 in the middle there. So the application does this all underneath. It's not even part of CX Oracle. It's all handled by the lower libraries. So that connection is created. It might be a rollback if something partial work was replayed, was there in the database. And then step 6 on the right, Oracle Client Libraries actually just replay all of those captured calls that they recorded. And on success, we return control to the application. So from the application point of view, everything just worked fine. Yes, there might have been a bit of delay where we had to get a new connection and replay, but the users won't know in most cases. At least they're not going to get an error back. Obviously, there's lots of sort of fine print, and this is the bits which fall in. Maybe things are stale. Maybe you can't replay. Maybe the data's been changed, so replaying what you just did doesn't make any sense. So there's a little bit of stuff you need to be aware there where it may not work in all cases. And there are obviously things with like sequence numbers, or you're doing an external call to a mail utility, do you want to replay that, yes or no? What about dates? So we have some controls over when you don't replay. So I want to run into Docker in the last 5 or 6 minutes that we've got here. I wish I'd been able to talk more. You should see the actual slides. I'm not showing you all of the great features that we have, but hopefully you'll come along to things like our office hours or follow the blog and also read our documentation. So we have some great technology now with Docker and Kubernetes and things like that. I just want to speak about it from, the client point of view, the CX Oracle point of view. For those who don't know Docker, it's a kind of virtualization technology. So they call it a container. It's available natively there, Windows and Mac. I tend to run mine in a VirtualBox on Linux, just because then I can throw it away and create it, and I don't stuff up my my day-to-day Mac environment. There's community editions out there which are great to use. So Oracle Linux Group support the Docker CE, lets you deploy applications, and we're seeing a lot of use out there. So one slide just before the demo, before I actually show you the bits. This is things I'm not showing you, which I've sort of pre-set up. Yum is the Oracle Linux package manager, so I'm just pulling in various packages, various pieces of software, and actually just basically installing Docker on my Linux machine. Yes, there are various things. You can set up proxies if you're inside firewalls, and if you don't want, as you see that I allowed non-root access, which isn't particularly secure, but great for demos, things you can set up. Then what you do once you've got Docker installed is you actually start pulling images. So this is a whole Oracle Linux Docker environment. So I can run this as inside Docker, I can run this and I just have Linux running. Obviously, I really want to put an application on, as I'll show you. But once you pull this, it'll go to the standard repository, pull that image down, and then I can list and see the images that I have. Now I'm showing you Oracle Linux. I know a lot of people like using lightweight images, or they like using, say, perhaps a Python image from the Python community. You do need to just check, what support situation is, whether you want the telephone support from Oracle and using a supported Linux kernel, etc. Also, I know some people like using Alpine Linux because it's small, but it's small because it doesn't have a lot of stuff. And by the time you add that stuff back in to work with Oracle, particularly the glibc library, then the size isn't significant, and also it's known to be relatively unstable. So I do recommend sticking with a kind of Oracle world. So let's have a look at Docker. So typically you just basically have a recipe file, so that you can see here I've got a directory on the right-hand side if you're seeing my screen. This is Emacs, split windows, shell on the left, directory listing on the right. Let me open up this Docker file. So this is just a recipe which says, how do I build another image? So I already start with one image. That's that one I just showed you how to pull. And then on top of that, I'm going to be adding some extra bits and pieces. So this is adding Instant Client. The name will change in a future version, but for the moment, this just it lets you install Instant Client, and then I install Instant Client. As of this morning, 19.9 came out. So this is already out of date. Doesn't technology change fast? So I ran this, and I have a vague feeling I'm still on the Oracle. No, I'm not still on the Oracle network, so I don't need my proxies. Hopefully this isn't going to do anything. And it isn't, because Docker has this great layering capability and caching capability. So it actually looked at these steps and then found that I had already run them before. So it already had these in its effectively Git repo, and it was using the cache. So I didn't have to redo all of these commands. So you get this great reusability. From the right-hand side, I'm already reusing the image that somebody created. Left-hand side, I'm just reusing caches. So I can go and add and augment this and change this, and hopefully builds will be relatively quick. So what I have here, actually I'll show you it all, because you'll see I've now created, and I should have explained this T is tagging, so this is the kind of name, repository name. The slash here is just the namespace separator, it's not a directory separator, but these slashes are the directory separators. So it's just saying, pick up the Docker file from this container, from this directory, sorry, which is the one I had on the right. So this is pulling down from the Oracle Yum server and just installing basic light, because I want the light version, which just has a few character set limitations compared with the full basic version. If I go up and look at the adding Python on top of that, there are various ways that I showed you that URL on the screen. There are some other examples there, and I have a great blog post about how to use Docker for this part 2, Docker for Oracle database applications. So there's a bunch of different methods you can use there as well. This is the one I chose, which is using RPM packages for Python, and then I'm installing using the pip command cxOracle from the PyPy repository. I could have used cxOracle from the Yum repositories, but being leading edge, I tend to want the latest of everything. So again, if I ran this, it would just use the cache, so I don't really need to run that. What it's doing here, though, is adding the work directory. So I'm just creating a directory on the machine and copying a file. If I go back to this directory, you see I have a demo file here. And it just copies that file inside the image that's there. And then when I run that image, so the image is just sitting there as a disk file, it's not doing anything. When I actually run that image, you can see that the command here to run, then it would actually execute this command. So I kind of build up an image, and then at runtime, I can decide what I want to do. So let's actually just run that. Well, actually, let me show you what the demo does. The demo doesn't do anything particularly much, just connects some environment variables, which I've now stored magically in a file on disk, so I don't have to share them around. And just prints out the version information, does a sys timestamp. Nothing particularly stunning with that, but in a 45-minute session, that's where we get to. So that just ran it. RM says clean it up when it's finished, so it doesn't remain around. Environment file, there's the environment variables. Gave it a name. If I had left it around, the name would be useful. And it just says which image do I want to run. The more sort of interesting thing is the next demo, which is this Flask demo. So this is a Docker file, which then builds on that Python file. And instead, it's going to run my demo at this stage, copies the demo in, installs this Flask module. So I have Python already installed, install Flask module, my app, and then going to run the app at runtime. The app itself is creating a connection pool, doing a init session. We've seen that kind of stuff before. And does some setup at startup time, just create some tables so that I've got some data. And then this is just my standard Flask app. So I have a few routes. I can post, I can add users. It's just letting it add users, really. It doesn't do very much except user names. And I can query. So I can specify the URL. And you can see the sample URLs up the top. So let me just run that. If I go back to the Docker file, oops, wrong window, and copy that. So I'll run that. And I realize the browser hasn't started, so it's just running as a daemon this time. So it's running in the background. Docker ps-a just lists everything. So I've now got this running. The name I gave it to you, Flask demo. And it's just sitting there waiting for requests to come in on this port 7000, which if I carefully open up my browser, which I'll just take a second on this little slow VM, then the demo app gets, whoops, that's just flashed off, sorry about that. Welcome to the demo app gets displayed, which was the code in the default root. And then I can add things like /1 on the end. Whoops, sorry, that's user /1. Let's try that. Let's open that. User /1, so it popped up Chris, which was the sample data I put in the top. Posting is very similar, so I don't need to show that, but I think we're just kind of out of time for that demo. If you look at the blog post, I do show you how to set up things like wallets for cloud database use, if you like. So That concludes the talk. I think we've just hit on the 46 minutes, so just a minute over. Let me just go and check whether you've got any questions. And I think the QA looks kind of quiet, which is good. But if there is anything, now is your time in the last minute or two before we get cut off to ask questions there. But other than that, thank you very much for attending, and look out for all the great content we've got coming up in future releases and already out there for you to use and create great applications. Thank you.
Thank you so much, Christopher, for your informative talk. And yes, if there's no more questions, then I guess I would like to say thanks to everyone for attending this session. And of course, there's still several sessions up until Friday, so you feel free to join and to register those sessions. And yeah, enjoy the rest of the conference and have a good day.
So I will say just one quick thing is I'm speaking about the Go language tomorrow and the Node.js language the day after. So I've got a couple more sessions coming up if you're also interested. There'll be some synergies, very similar things to the things we've discussed today, but obviously focused on those particular environments. Enjoy the conference.
Okay, thank you.